One of the most important discoveries made in science is electricity. Electricity has influenced our lives and the way we live in many ways. From a smartphone to an electric train run on electricity. Let's define what is electricity. Electricity is flow of charges. We know that every matter is made up of atom, and atom consists of electron, proton and neutron. We can see in this diagram proton and neutrons are in the nucleus of the atom, and electron revolve around the nucleus in different orbits. Protons are positively charged particles and neutrons are neutral, they don't have any charge, and electron is negatively charged particle. Here it is also important to discuss that protons are strongly held by the nucleus by a very strong nuclear force, whereas electrons are loosely held by the nucleus. So, by supplying a little energy, we can have this electron out of the orbit in compared to the proton. Proton is not easy to take out of the nucleus, just providing a small amount of energy. Here I have said that, as I have explained, flow of charge is called electricity, and there are two types of charges: positive charge and negative charge. Now let's have a look what actually charges are. A property associated with the objects by which they show electrical and magnetic phenomena is called the charge. You must have seen current flowing. If not seen, you must have experienced current flowing in a wire. This is because of charges possible. I have drawn here a circuit in which I have taken here a conductor. Conductor can be anything like copper wire or iron wire, aluminum wire, silver wire. Most of the time copper wire is taken because it is cheap as well as a little good conductor. And here I have taken a battery. This is a battery. Here I have taken a battery. Battery having two terminals, positive and negative. This is positive terminal, this is negative terminal. Here positive particles are accumulated, here negative particles are accumulated, and here in between chemical reaction take place. And let's see how charges flow in a conductor. As I have defined that flow of charge is called electricity. Let's see how charges. This is a conductor, and conductor having positively charged particle as well as negatively charged particle. Here I have marked. Only we will consider that here electrons will flow because electrons are available in a conductor in plenty. This battery having two terminals, positive and negative terminals. Negative terminals, electron pushes the electrons in the connecting wire, and electron flow from A to B in the circuit. Actually what happens here, really electrons does not move. They supply the energy to the neighboring electron, and the next electron transfer its energy to its neighboring electron like this. This electron transfer energy to this electron, and so on. And so roughly I can say electrons moving from A to B and in the conductor C to D. when one electrons leave this terminal negative terminals, there is a depletion of electron over here, and the electrons coming in this direction towards B, and here neutralize the positive charge, and there is a deficiency of positive charge also here, and there is a depletion of a negative charge also here, and this is compensated by the chemical reaction taking place here. And in this way, as long as chemical reaction taking place, this electron keep on moving in direction A to B, and continuous flow of charges maintained by the battery. This is the direction of the electron flowing in the circuit, but this is not the direction of the electric current in the circuit. Electric current direction in a circuit is opposite to the flow of electron. What is the reason behind it? That also I am explaining you. This is movement of the electron. Electrons are moving A to B, but the actual direction of current, the direction of current is B to A. Why the direction of current? Why the direction of current is taken opposite to the direction of flow of electrons? The reason being is that the concept of electricity was established even before the discovery of electron. At that time, it was supposed that the flow of positive charges is the direction of current. That is we call conventional direction of current, means in the direction of positive charges. But later on, after the discovery of electrons, it was found that in a conductor the current is flowing due to a negatively charged particle, and that time the conventional direction of electricity had already been decided, that was positive to negative. Therefore, it was not changed later on, and still we take the direction of current electricity direction of current from positive terminal B to negative terminal A. So every time whenever I use the electric current, you will keep in your mind that the direction of current is B to A always. As we know that electrons are flowing in the circuit, and electrons having a very small charge 1.6 into 10 raised to power minus 19 coulomb. If suppose for the time being one electron is flowing in this conductor, how much current will be flowing? Surely a very small amount of current must be flowing, and that cannot be even measured because we don't have very sensitive, that much sensitive device which can measure that amount of current. But it cannot be neglected that there is no current, but obviously very small current. It means when a big amount of current flowing, at that time a large number of electrons must be flowing, must be participating. And let's now have a look. Suppose I have taken this cross section area of the conductor. Cross section area means thickness of the conductor. This is we call the cross section area of any object. Vertically, if you cut the object and the area you getting that this is a circle, and a circle area is the cross section area of this conductor. So I have taken here cross section area. First let's define the electric current. Electric current. Electric current is amount of charges. Amount of charges means I am talking about the electrons. Electric current is amount of charges flowing through this cross section area per second. Electric current is amount of charges flowing through this cross section area per second. It means I can write it like this: electric current equal to amount of charge divided by time. Symbol of electric current is I, and amount of charge I am taking Q, and the time is T. So amount of net charge flowing through this cross section area per second is called electric current. For the electric current I have used the symbol I, and for the amount of charge passing through this cross section area I have taken Q, and time I have taken T. So if I write here, I is equal to Q by T. This is very similar to your formula, speed is equal to distance upon time. Distance covered in unit time is called the speed. In the same way, amount of net charge means these electrons I am talking about, electrons flowing in this direction. Amount of net charge passing through this cross section area per second is called electric current. So electric current I is equal to Q by T, same as S is equal to D by T. For the time being, we remember this formula. We will discuss later on about this topic.